So let's do now the second derivative of my utility function in respect of Ks. So we follow the same procedure as in the first case. So first we start in our beginning period, t, and you can say, just to simplify it, t is 0. Then we have, once again, the beta is to the power of 0, so it's 1. Then the first derivative of my consumption function in period s. And now we have to calculate the inside derivative of my capital. Well, once again, this is then t, but t is 0. Well, these are then all constants. But then we have here this one. Yeah? Because if this is t, s is equal to t, and t is 0, then we have the capital stock in period 1. That is already a number, and therefore we can calculate the derivative of this. That gives me -1. So times -1. All the other terms are 0, the derivatives. Then we continue, plus next period. In the next period, we have again the beta. We have again the derivative of the utility function s plus 1. And now we calculate the inside derivative. Now we have here s t plus 1. Yeah? So this is, because here is capital, so I have to calculate this derivative. So we have s plus 1, derivative of my production function at s plus 1. That's the first term. And then for t plus 1, yeah, I'm now in the t plus 1 step. You see, this is then t plus 2. Does not matter. But here I have t plus 1, yeah, for s, t plus 1. But t is 0, so that's then in k1. That's in the first period, in the next period, not k0, it's k1. And now I calculate the derivative of k1. So the derivative of this is 1, but we have minus and minus, so this is plus 1, right? So it's plus 1 equal 0. So again, this is the first derivative of my utility function in respect of Ks. First is the first derivative at S0, and then in the next period at T0, yeah? And this is, you can say, at T1, the derivative at T1. And if we have two periods, then this is repeating, and therefore we can stop. And now we can, once again, similar to the case we discussed earlier, we can a little bit rearrange this condition. And to do this, once again, let's move this on the other side. Yeah? Then we have beta times the derivative of the utility function. Then we have as plus 1 f prime ks plus 1 plus 1 is equal to, this is now on this side, the derivative of consumption at consumption in period s. Next, why not moving this term here in the denominator of this term? Yeah, so I divide the whole equation by this term, then we get a 1 here, and this term pops up here. Right? So this is just rearranged. And from the Euler condition, we know this term is equal to 1 over 1 plus r. Right? So for this term here, in front of this bracket, I can also substitute in here 1 plus r. Because the Euler condition, when you look back what we did here earlier, we have seen that the margin rate, the intertemporal margin rate of substitution is equal to the price ratio, which was 1 over 1 plus r. So I can plug in here 1 over 1 plus r, and then I move the denominator on the other side. And then I have just what is here in the bracket, plus 1 And the denominator, it's just the 1 remains here, is this 1 plus r term then here on the right-hand side. So I plug in this here, and I multiply the whole guy by 1 plus r. That brings the 1 plus r here on the right-hand side. And now we are very close to the final point. So now we have this left-hand side is equal to the right-hand side. On both sides we have 1. So let's cancel this 1. And then we get the final condition. And maybe I write the final condition here. This is my a s plus 1. So the derivative of the production function at s plus k s plus 1 is equal to r. So this is the optimal condition we obtain from the optimization of the utility function in respect of my capital stock at period s. So what is the meaning of this? Well, the left-hand side, you see, that's a derivative of my production function. And we call this, that's a marginal product of, because my production function is dependent on capital, of capital. That's a marginal product of capital. And on the right-hand side, this is the price of capital, the interest rate. So in optimum, the marginal product of capital must be equal to the price of capital. And that is also what you studied in microeconomics, that the marginal utility must be equal to the price you are willing to pay for one additional unit of consumption of a good. And here it's the marginal product of capital is equal to the price of capital, but the price of capital is the interest rate. And you can also illustrate this graphically, similar to the case of graph we already did here for the utility function with the indifference curve and the budget constraint. Here we have the derivative of the production function. And do you remember the name of the derivative of the production function? So the derivative of the utility function is called the indifference curve. And the derivative of the production function, same properties, and also it also looks like a downward sloping curve. It's called the isoquant. And this condition is basically then the isoquant, which is this downward sloping curve, is equal to the price ratio, that's the slope here, of this constraint. So it's the same graphical shape just for the production function here, and the first condition it was for the utility function. You can say this is production theory, what you discussed separately in micro, and this is utility theory, household theory. And here we have a model where both are in ones, because it's a macroeconomic model. It's not just consumption, household theory, it's consumption and production. It's a macroeconomy. In macroeconomics, you discuss first this, and then after a couple of weeks, you discuss the production side. And here it's all in once, because it's about the macroeconomy. So what I can tell you here, just from this computation, you will see we are not really needing all of this in a second, but what I can say definitely, I can find optimal conditions. I can find the optimal consumption over time periods, and I can find the optimal capital stock in period S and period S plus 1. So I can find the optimal points, and that is guaranteed by the computation in a way we did so far. What I'm going to do next is I go a step back. And what I do, I once again look a little bit closer to my budget constraint. And what I hope by this, by looking closer to the budget constraint, to get a condition that this budget constraint is telling me when a country is sustainable or solvent, and when a country is bankrupt or insolvent and unsustainable in a way. And what we will see, we can really find this by taking a closer look to my budget constraint. and this optimization problem. So we are not caring about the optimal consumption levels, yeah, what we did here. We are more caring to get a condition that comes from my budget constraint to assess whether this country is bankrupt or not. Okay, so now what I'm going to do, I once again write down my budget constraints, which we derived already. I think it was my equation 2 or so. And the budget constraint we derived was 1 plus R, the net foreign assets in period T on the left-hand side. And then we had, on the other side, we had consumption plus investment plus government spending minus GDP plus the net foreign assets in period T plus 1. So at some point in our earlier discussion, we derived this constraint. And this constraint it's a little bit strange. Why? Well, it's strange because all the variables except one are in the same time period, right? This is period T, 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 T plus 1. Yeah? So there is one time period going into the future ahead. And the question is now, I want to find a constraint that is true for all periods. Yeah? So how can we maybe eliminate this future net foreign assets? Yeah? Can we eliminate this BT plus 1? And now I will show you a kind of trick how to argue that we can really eliminate this. And the idea is the following. So let's call this is my budget constraint. So let's call it budget constraint, yeah, in this period. What I can do now, I shift this constraint one period ahead, by one period into the future. So what I mean, so shift in to future. Well, if I do this, then I just have here, instead of T, T plus 1. Yeah? So then I have, if I shift this in the future, I have here then BT plus 1 is equal to consumption T plus 1, investment in T plus 1, government spendings in T plus 1, T plus 1. And then, of course, I have here T plus 2, yeah? Because I just shift this into future. No problem, no big deal so far. Now, next step, let's divide this new equation by 1 plus R. Yeah, well, if I divide this by 1 plus R, I get rid of this here on the left-hand side. Yeah? But then I have here over 1 plus R plus the last term over 1 plus R. You can also write this as a common denominator, but you will see why I split it up in two terms in a second. So we have this condition, also no big deal. But now the trick is the following. So what we see here now, we have on the left-hand side BT plus 1, right? Why not substituting BT plus 1 in the initial budget constraint? And then I have this term, well, and then I have BT plus T plus 2. Okay. You wonder, what is really the benefit of this? So far, nothing. But we can repeat, right? We can once again shift this constraint a period ahead. Then we have here T plus 2. And then I can substitute the T plus 2 we have here with this new term. And so on and so forth. And by doing this, we get the following budget constraint. Yeah, after a couple of iterations, maybe we have to do this at home. Yeah, really substituting now this guy in here, moving this ahead a period, and moving then back in here, and so on. And then what you will see, you get the following condition. It's the sum of this 1 plus R S minus T of this first term, consumption, investment, government spending, minus output. And then we have a final term, which is at capital T for BT plus T plus 1. So if I really do this iteration over several time periods, then what I obtain, the left-hand side is still what is here. I obtain a sum of this, and then I obtain this final term, which is always one period ahead. The final BT remains. Yeah, I cannot eliminate all the BT, but I can just have then at the end a final BT plus 1. Can I show you that this is really what pops up? Suppose T0 again. T0. Sorry, we start at T. Yeah, you can also say T0, but if I plug in the first T, you have T minus T, that is this fraction to the power of 0. Well, to the power of 0 is always 1. Then you just have this term, which is the first one. And then in the next period, T plus 1, you have this 1, which is 1 over R. This is this 1 over R, and then you have here T plus 1, or which is then S plus 1, yeah? Which is exactly this term, this first term. Yeah? In the next period, you have this squared, and then you have S plus 2. Yeah? And then you always have these, the sum of all these terms, yeah? From this to T plus, and so on, plus always this final term, which is one period more. Therefore, we have T plus T, that's the final, and then one BT, which is more than that, this plus T. And this budget constraint is now very important. So take a close look to this one. To make it even more meaningful, let me discuss in more detail this final BT plus T plus 1. And what I'm arguing for is that this BT plus capital T plus 1 is 0. This term is 0. I will explain this to you next, and this has a special name. And let me first tell you the name. This is called the no Ponzi game condition. So this assumption, you can say, that this final net foreign asset term, the net debt I have, is 0. And we call this the no Ponzi game condition. So what is this about? That is critical to understand, but I'm pretty sure you can understand this. So think about the debt. Yeah? Think about this is debt you are holding, right? If you have not a current account surplus, if you have a current account deficit, then you are not getting money, you are having debt against another country. And what this condition is now telling us, the final debt of my country, or think about you, at the end of my life, yeah, that's really the end of your life. Let's say here you die, yeah, and at the end, I cannot die with debt. That is what I'm claiming. Think about, if you take a credit, then the bank will only give you a credit if they know you will pay back the credit until you are here on Earth. If you cannot get a credit over $1 billion, because the bank already knows, given your income, you never can pay back this, you will not get this credit. You cannot get such a huge debt level or amount if you cannot guarantee to pay back this. And what I say here is, you just get a certain level of debt that you can really guarantee to repay. And therefore, at the end of your life, your debt level must be 0. You cannot die with a positive debt. And that is what the no Ponzi game condition is telling us. And why is it called a no Ponzi game condition? Because a Ponzi game is the opposite. And maybe some of you have heard about an investor during the financial crisis, Bernie Madoff, a US guy. And what he did, he established an investment fund and he made a Ponzi game. And how has this Ponzi game worked? Well, he offered to the investors a very high rate of return, higher than the return he can achieve by investing the money. And how has he paid off then the investors? He has attracted new investors, and then he has paid the existing investors by the investment return plus the money he got from the new guys. Yeah? And so he was able to offer such really high returns. But at some point, you know, when you get not the new investors to pay off the existing investors, you see that cannot go on. Because at some point, you pay out more than you have return from your investments. And that is what we call a Ponzi game. And this is illegal. This guy is now in jail for a lifetime. Yeah? And it's also not, it does not work out in the longer term, right? And I exclude such Ponzi games with this condition. I say it's not allowed to die with debt. Yeah? So I can only take a certain amount of debt which I can guarantee to pay back. And this is a critical assumption, yeah? But it totally makes sense in reality. And in a dynamic optimization problem, this whole term, yeah, so with this discount factor, 1 plus r, is sometimes also called, I will just call you and tell you the terminology, sometimes also called the transversality condition. Transversality condition. So if I take a look to the whole term, including the discount factor, yeah? So this, if I assume this is 0, it's called the no Ponzi game condition. If I take a look to the whole term with the discount factor, we call that the transversality condition. Anyway, this condition, as I argued, is 0. So in other words, I can eliminate this from my budget constraint. And that was my ultimate goal, yeah? To get rid of these higher debt terms. And then my budget constraint has simplified. Yeah? So let me write down now the simplified budget constraint. Well, on the left-hand side, we still have 1 plus r. T is the sum from S equal T to T capital T, 1 over 1 plus r. And then we have what is here is consumption in period S plus investment in period S plus government spending in period S plus output in period S. Okay. So you can say this is what we call the intertemporal budget constraint. Yeah? This is an intertemporal budget constraint. And this intertemporal budget constraint offers us now the first insight about when is a country sustainable or closer to bankruptcy, let's say. So how can you see this? Well, first of all, on the left-hand side, you can say, well, these are the net foreign assets in the initial period. And to make this a little bit more clear, let me multiply the whole constraint with -1. Yeah? Then this gives me a plus. Yeah? So we have then here a plus, then this turns into a minus, this turns into a minus, we have a minus here, and we have a minus here. Yeah, so I just multiply this with minus, which is quite easy to do here on the board. And you will see why this makes sense to do to get a better understanding. Because on the left-hand side, what I can say here, this is now my initial debt I have as a country. Yeah, this is the initial debt of net foreign assets, yeah, of net foreign assets. Yeah, this is the debt I'm holding, and at some point I have to repay this debt to the other country. And this must be equal, in the longer term perspective, to what is here on the right-hand side. But what is on the right-hand side? Well, this is my income, GDP, minus consumption, minus investment, minus government spending. So what you can say, what is here, is the net wealth we create, right? We create every year a GDP. Why? And if I subtract what I consume from my GDP, what I invest, what the government consumes, I have a wealth creation in this country. And this is you can say that's the net wealth of this economy. Yeah? That's the net wealth, or the creation, net wealth of the economy I'm living in. However, it's a little bit more than that, because it's, that's the sum of all the future net wealth I create, right? This is you can say that's a present value net wealth. It's a present value. It's all the future income discounted with your real interest rate. So every period you create GDP, you produce, and then you discount for every period this with a discount factor 1 over 1 plus r. So what you have here is a present value of net wealth of the economy. And now this condition is telling us the following. The initial debt I'm holding must be equal to the future wealth, the future income I can expect. If my future income cannot compensate and pay back the initial debt, well then there's an imbalance, right? And that may indicate for the first time that there's something wrong with this economy, right? So if you cannot create net wealth, then you cannot pay back the debt you are having today. So this condition can be simplified even further. If you take a close look to this, well, we see immediately in output, GDP, minus consumption, minus investment, minus government spending, this is actually equal to net exports. Think about the income expenditure identity. If I move these components to the output side, what remains here is net exports. So, in other words, if I have a debt stock at the beginning, to compensate this, to repay this initial debt stock, this must be equal to the discount of my net exports. And if the debt stock is positive, so if I have debt, I need, obviously, surpluses, current account surpluses, or net export means I export more than I import in future. So sustainable countries, in terms of holding net foreign assets, requires, if you hold net foreign assets, a current account surplus, a positive net export term in the future. Yeah, the discount of the net exports in the future must be positive. Otherwise, you cannot have this equality, and otherwise you cannot pay back. If you have no surplus in your current account, you cannot pay back your initial debt. And to make this a little bit more clear, I simplify the model now, a little bit, to get really a very precise condition. And that is my last step I have to show you. So now to derive a very clear, precise condition, which we can plug in numbers and calculate a number to assess whether a country is closer to bankruptcy or not, I just assume the following. Well, it's not an assumption, I just simplify this condition in a way. I say, suppose that this 1 over 1 plus r is equal to my discount factor I already introduced in the utility function. This is equal to my beta. This is my discount factor. And now take a look to this sum. So if I have the sum for ST, and instead of 1 over 1 plus r, I can also write this as beta. And this is beta to the s minus t. And if I allow that this is now running not for a capital T, if I assume that capital T is running for infinity, now I assume an infinite time horizon model. So this sum is an infinite sum, then you can write down this also. This is 1, right, in the first period. Then you have beta, beta square, beta cube, plus until infinity. And this is, fortunately, this is a convergent sum. And this can be described as 1 over 1 minus beta. So if you sum up all these discount factors until infinity, it runs to this number, 1 over 1 minus beta. That's a convergent sequence. But as you know, well, beta is 1 over 1 plus r. So I can rewrite this, yeah? Instead of plugging in here beta, I plug in back 1 plus r. Yeah? And this can be then, if you find the common denominator, you see immediately this is 1 plus r over r. Yeah? Common denominator, then you bring the 1 plus r up, and in the denominator you just have the r. So in simple words, this sequence of betas is equal to that. And so what I'm going to do next is I assume that we do this summation here, not just to a fixed t. I assume that t is now infinity. And then what you can see that I can, instead of 1 over 1 plus r in this sum, yeah, I can rewrite this sum in front of my bracket here. Yeah, I can rewrite this sum as 1 plus r over r. Yeah, that was my argument here by substituting first this term as beta and then see that this is a sequence. We know that this converges to this level, and bringing back for beta my definition of 1 plus r, I see immediately, okay, this sum, this term here can be written as 1 plus r over r. So in this case, obviously my budget constraint simplifies. Yeah? So I can say, well, this is now 1 plus r beta bt. And then we can say, okay, instead of this, we have this 1 plus r over r. Yeah, and then we have this income minus consumption minus investment minus government spending. And now I'm very close to what I'm going to do. What I'm going to do next is I factor out, I bring the consumption level in period S on the left-hand side. Yeah? So I move the consumption on the left-hand side, so I have to multiply what is here in front inside the bracket, and then I move this on the other side. Then you can say, well, I have then 1 plus r over r equal consumption on this side, and on the other side I bring this term now to the right-hand side, so I have then 1 plus r b at period t, and the remaining period is this term, 1 plus r over r, and what is remaining is income minus investment minus government spending. So this is what I have now here, right? I just moved this term on the left-hand side, then this on the other side, and the remaining terms are here. And actually, I just want to have consumption on the left-hand side, right? And not 1 plus r over r times consumption. So let's move this term on the other side. Well, that's not too difficult. The r pops up here, and the 1 plus r is then down in the denominator here. And this is gone. And now we have a condition that is telling us the consumption in period S, in a certain period, must be equal to the right-hand side. And what is the right-hand side? Well, the right-hand side is the existing debt. Yeah, you have some debt. And then you have also here the discount of the income you create in your economy, right? Income minus investment minus government spending in period S. Yeah? So this is once again the kind of net foreign wealth, yeah, the present value of the net foreign wealth, like we had here in the more general budget constraint, but now just for one period. So, so what can we say? The consumption I can do in period S can be in maximum the debt, yeah, the existing money I have borrowed, plus the money I create by production. If I consume more than the money I'm holding and the money I create in my economy, you see, then this is a kind of imbalance, right? I can consume only, think about you, if you have a mortgage, yeah, you can consume, you can take this money plus income minus all the other investments you did. Yeah, and the remaining income, that's the net foreign the net wealth, so the net income you have, that is also what you can use for consumption today, and nothing else. So whenever this is in line with the spendings, the consumption spendings today, it works out. Whenever you consume more because you consume more than the initial debt you have because you take further credits and so on, but these further credits are not able, if you're not able to repay the further credits by future income, well then you get an imbalance. And to make this more clear, if you take again a look to this more general condition, you see immediately that when a country has net foreign assets, when the country is holding net foreign debt, you need, as I told you, current account, sufficiently large current account surpluses. So to assess whether a country is in line with this condition, that means the country is sustainable. If you are able to create surpluses in future, then you can repay the initial debt. Of course, to assess this condition requires you have to estimate what is the output, yeah, in future. What is Germany producing in the next period? Can we really repay our initial debt? Requires that we have to think about what is the value creation, the wealth creation in future, right? It's a sum of all the future, you can say, current account surpluses we create. To do this forecast is obviously a difficult task, right? Because it depends on economic policies. If the German policy, economic policy, we don't know what they are doing tomorrow, we don't know what they are doing next year, what they are doing in 10 years, right? So it's quite difficult to make these forecasts, and therefore really assessing whether a country is sustainable or not is a very difficult task. Because if we want to be very precise, well, we have to do these forward-looking procedures. And this forward-looking procedure is quite hard to do. There is a second point which I have eliminated here. I am talking about the small open economy and assume the interest rate R is fixed. But some countries, if you think about the Greek economy, the Greece, right? In 2010, at some point, the market thought, well, Greece is bankrupt. They cannot pay back. And at that point, the interest rate also changed dramatically. The interest rate jumped up. So if the Greece economy want to have future new debt, well, they had to pay a far higher interest rate than a year ago at that point. And that is also not included in this model. So maybe also the interest rate is changing dependent on investors' sentiments. And what you can create, which sometimes happens in financial market, are so-called self-fulfilling prophecies. So if you believe that the country cannot pay back, it's similar to a bank run, we already have talked about a little bit, right? Then everybody thinks, okay, the country cannot pay back, and then the interest rate jumps up dramatically, and you have a kind of discontinuity, which is also not modeled, because I assume that the interest rate R is fixed in this model. And the final point to this, assessing this general condition, whether countries are sustainable or unsustainable, is the following. The whole optimization only works out if we assume that the interest rate R is positive. When the interest rate R is negative, the whole argument breaks down. And you can see immediately why this is the case. So last week we have talked about low interest rates, right? And the central banks around the world, even the ECB has cut the interest rate 2 weeks ago, not only at the zero lower bound, now at zero. And obviously from zero to negative, and we discussed this last week, it's a small step in a way. Yeah? But what happens, think about what happens if we really have negative interest rates, or if we assume negative interest rates. And the craziest thing is, all the arguments, all the textbook models we have in economics, that they are consistent. They are only consistent if interest rates are positive. All the models we have break down, and the whole arguments break down, if we get negative interest rates. First of all, take a look. If we plug in negative interest rates here, you see, well, this is 1 plus minus something, but here we'll get a negative number. That means consumption is negative. What means negative consumption? Well, that means more saving. But this does not make any sense, because if you have negative interest rates, well, then you are not saving, right? Because your saving are also declining. But this condition would telling you this, that is what you will do. You see, that does not make any sense if we plug in negative interest rates here. So the whole optimization argument and the whole equations we derive make only sense for positive interest rates. And therefore, it's completely unclear what will happen if central banks really go with the main refinancing rate, with the key interest rate, into the negative territory. We have just the deposit rate is now negative at minus 0.4. The key interest rate is still at 0. But if they really go down with the main refinancing rate in the negative territory, nobody knows what is really going on. Think about the no Ponzi game condition we have talked about. Even this argument breaks down if we have negative interest rates. Because then you get credit and you get on top money if we have negative interest rate. Then you can play a Ponzi game. Why? Because you can always pay back the credit you take, because you always get more when you take a new credit. So the no Ponzi game constraint we talked about, and I introduced this about as a reasonable constraint in normal times, makes only sense if credit has positive interest rate. If the interest rate is negative and you can credit on top money, well then it's not a constraint, because you can take a credit of $1 billion, no problem, you can pay back the $1 billion because you get more money in the initial period. Yeah? So even the no Ponzi game constraint is not in line with negative interest rates. And so there is a whole discussion going on now in theory. What does this imply, negative interest rates? How will people change behavior? And we can see that all this makes only sense if we assume that the interest rate is positive. And now my final step I'm going to do is the following kind of case discussion. Yeah, a simple case study. So I assume that GDP is growing by a certain growth rate G. Yeah, so my GDP in period T grows by this growth rate, and then we know the GDP in future, right? This is a way to compute this. Yeah, the future GDP. If we know the existing GDP and if we know the growth rate, we can immediately get the future GDP. And now let me also assume that the debt stock over GDP, you can say debt to GDP ratio, the debt to GDP ratio is constant. So my debt stock in respect to GDP, this ratio is not increasing over time. So suppose that this should be holding at a sustainable, at an existing constant level. Yeah? If we assume this idea, well then you see that the debt can in maximum grow also with the GDP growth rate. If the debt stock is growing with the same growth rate as my GDP, well then the debt stock remains constant. Can you see this? If I write down this for st plus 1 over ys plus 1, and if I plug in this and this, well, you see this is the same because 1 plus g cancels out. Yeah? So this is also constant. If we assume that my debt is growing not more than my GDP growth rate, yeah? Then all these debt to GDP ratios remain constant. So if this is the case, then let me go back to my current account discussion. We defined the current account as the difference of the net foreign assets. That was my, at the beginning, my definition of the current account is equal to the capital account, which is measured like this. And for BT plus 1, in this case, yeah, I can substitute now in this 1 plus G plus BS times BS. Yeah? So if I plug in this here, and if you multiply out this, oh well, let's do. So I plug in this here is minus for BT. Well, then I write it down for S to make it consistent. Yeah? Then we have this. And if you calculate this, you see middle, that is BS minus BS cancels out, so this is just growth rate times net foreign assets in period T. And this, if you remember, that was the second definition of my current account, was income plus the income of the net foreign assets, the return of net foreign assets, minus consumption, minus investment, minus government spending. That was my second definition of the current account from the income expenditure identity. And once again, if I equalize now these two, yeah, so if I write down for the current account here on the left-hand side, this is equal to growth rate times the net foreign assets in period S, I get this condition. And if we take a look, output minus consumption, minus investment, minus government spending, right? That's the same what we have here. This is, you can say, the net export or the trade balance. Yeah, this is a net export. So I can rewrite this condition as if I bring B on the other side, then I have minus R plus G, because I have the minus here. I get it like this. And then I have the circled area, which is, let's call it net export in period S. I can write down this in a short frame, in a short way like this. And from this condition I get, that's my final point, what I'm looking for. If I divide again both sides by GDP, then I have minus R minus G divided by GDP, and I have to do this on both sides, of course. I get such a condition. Yeah? So I take this and divide on both sides by GDP, here and here. I have this. So what can we see from this condition? Well, I assume that my debt, the B, yeah, I started with this, the case. I started my case with the assumption that the debt to GDP ratio is constant. Yeah? This is the debt to GDP ratio is constant. Yeah? Okay. And if I have some debt, that is what we see, we need positive surpluses. Yeah? Because output is positive, that's what we produce. No question, that's positive. But to make this right-hand side positive, we need also that net export is positive, right? We need a positive net export. Positive net export, and positive net export means we export more than we import. So if we have some debt, yeah, then we can only compensate this debt by surpluses. So if a country like Greece has a lot of net foreign assets, right, because German money over some time was flowing to the Greek economy. And now the question is, can we get back our money? Well, we can only get back our money, yeah, this debt, what they have, if they also have surpluses in future. And here's the question: can the Greek economy really achieve over longer term such surpluses, such a level of surpluses that is equal to the debt they are holding from other countries? Yeah? And furthermore, what we can now do, we can calculate this number. Well, we can calculate the right-hand side number. We just look to what is net exports over GDP. In the Greece case, we know net exports are negative. And therefore, you see immediately there is an imbalance, right? Because they must be positive. But they are negative in the Greece case. We can also, we know what assets they are holding, we know GDP, we can estimate the growth rate, in the past at least, yeah, the average growth rate, we can take a look to the real interest rate, and then we can calculate so-called ratios. And that is what I'm going to show you next on my slide. And by the way, here there's also an assumption, and the assumption is that R, the real interest rate, is greater than the GDP growth rate. Yeah, when this is the case, only this makes sense, because if we assume that the real interest rate is less than the growth rate, once again, then a debt stock moves into something I'm holding, right? It moves into the opposite direction. Then it does not make any sense. Yeah? So it's only, this condition makes only sense if we also assume that the interest rate is greater than the GDP growth rate. And this is, by the way, in normal times. In normal times, let me emphasize this. This is the case. Yeah. So this holds for if we look back over the past 100, 200 years. Yeah. This is the case. So now let me show you this table. And for instance, in Argentina, what you can see, well, that this really number raised, right, from a half percentage to now 4. Well, this is indicating that this country now needs a surplus of 4% in respect of GDP, which is quite a lot, because even Germany, which is a surplus country, has only 1 to 2% of GDP export surplus. Yeah. So this is already indicating, yeah, probably that at some point this country cannot really repay the existing debt, because the surpluses they need to repay is almost impossible to achieve. Yeah? So to assess in the end sustainability, you can just look to these numbers to get a feeling, yeah, and compare it maybe with other numbers whether a country is more or less sustainable. There are other interesting cases, for instance, Thailand. Yeah? So you see Thailand, the number has changed only a little bit from 0 to now 0.2. And this is despite, in this time period, despite a sharp increase of net foreign assets in Thailand. So the debts, the foreign debt, increased significantly between the 1970s and 1991. But this ratio, almost only a little bit. And the only reason is why this is the case is because Thailand also experienced in that time period a very sharp increase in GDP. And as you see immediately, if GDP raises significantly, yeah, if this number gets up significantly, then this ratio falls down. So you can compensate, of course, some of the debt you're holding if your own economy is growing at a fast rate. If the GDP is growing at a fast rate, then that will also help you in terms of repaying your debt, because the debt is always denominated with GDP. And if GDP is growing, if this number is growing, well, then this ratio gets down. Yeah? And that was the case in Thailand, why the Thailand ratio has not increased so much, despite the debt. Yeah? Just the level of debt has increased significantly in that time period, but the ratio not. And therefore you can say it's still sustainable as soon as the GDP growth rate continues at that speed. Well, we see some other countries, right, in particular Nigeria, that is really at that point indicating that they have not sustainable policy and cannot really repay. We also have Chile, Hungary, which have also relatively large numbers in comparison to the 1970s. So this, as I already said, this is a table out of a book, Foundations of International Macroeconomics by Obstfeld-Rogoff, and they did this calculations based on this ratio. And obviously you can also do this for every country now. You just have to collect, you have to look to the statistics. That is what you can find for every country, the net foreign assets, GDP. And then you have just to take a look to what is the growth rate or estimate the growth rate, what is the real interest, what is the real return. And then you can get a feeling about whether a country is sustainable or unsustainable. Whenever this ratio is relatively large in comparison to solid countries, for instance, like Germany or so, you can really say, well, here's a sustainability or a problem with the sustainable debt levels. And this is what people do if they talk about whether they can really pay back the debt or not. And a country is assessed to be bankrupt if this rate is, in respect to GDP, is relatively large in comparison to some other solid countries. Okay, so that's it about the question: when is a country bankrupt?